June 6, 1944, Omaha Beach, Normandy. 7:30 hours, the sand is red. Not the pale beige of a peaceful shore, but crimson, saturated with the blood of men who will never see home again. Sergeant Curtis G. Cullen crouches behind a disabled Sherman tank, its tracks shattered by a German mine, its crew evacuated to the dubious safety of a shell crater 20 yards back. The air tastes of cordite and salt and copper. Above the beach, hidden in the Norman hedgerows that checker the inland countryside like a vast green maze, German machine guns chatter in rhythmic bursts. The invasion is 6 hours old and already it teeters on the edge of catastrophe. Cullen presses his back against the tank's blood-warm hull and closes his eyes for 3 seconds, no more, allowing himself that brief respite before his mind returns to the problem that will haunt him through the coming weeks. The problem is not the beach. Thousands of men are solving the beach, paying for each yard with lives and courage. The problem waits inland in those hedgerows, in that ancient agricultural labyrinth that no intelligence briefing adequately warned them about, no training exercise prepared them for. The problem is that the American Army has brought the finest tanks in the world to a battlefield, where tanks cannot maneuver, cannot see, cannot fight. And Cullen, a tank commander from New York who fixed cars before the war, understands that unless someone solves this problem, the liberation of France will drown in Norman mud and American blood. The hedgerows of Normandy had existed for centuries before American soldiers encountered them. Norman farmers had constructed these living walls over generations, piling earth and stone to create boundaries between fields, planting thick hedges atop these mounds that grew into impenetrable barriers 12 feet high and equally thick. The roots of hawthorn, oak, and bramble intertwined with earth and rock to create structures as solid as concrete walls. Between these hedgerows lay small fields, seldom larger than a few acres, connected by narrow sunken lanes that centuries of use had worn deep into the Norman clay. From above, from reconnaissance photographs, these hedgerows appeared as simple field boundaries, pastoral and picturesque. From ground level, they constituted a defender's paradise and an attacker's nightmare. American military planners preparing for the Normandy invasion had studied terrain, beach gradients, German fortifications, road networks, and countless other variables. They had not adequately studied the hedgerows. Intelligence reports mentioned them, classified them as agricultural features, noted their presence without grasping their tactical implications. The planners anticipated mobile warfare, rapid breakout from the beaches, armored columns racing through French countryside toward Paris and the German frontier. They had prepared for the Normandy they expected, not the Normandy that actually existed. This failure of imagination would cost lives, would stall the advance, would transform what should have been a war of movement into a grinding, attritional nightmare where each field became a separate battle, and each hedgerow a fortified position. The German defenders understood the hedgerows intimately. Many of the Wehrmacht units stationed in Normandy had occupied these positions for months, had studied this terrain, had transformed it into a defensive system of extraordinary strength. A single German squad positioned behind a hedgerow could command an entire field, their machine guns and rifles covering every approach with interlocking fire. Mortars pre-registered on likely American assembly areas could drop rounds with devastating accuracy. The hedgerows channeled attacking forces into predictable routes, created killing zones where German artillery could massacre entire companies. Most critically for the armor battle, the hedgerows negated American tank superiority. A Sherman attempting to cross a hedgerow would climb the earthen bank, exposing its thin belly armor to German anti-tank weapons for the crucial seconds required to crest the obstacle. German Panzerfaust teams learned to wait for this moment, to hold their fire until the American tank presented its most vulnerable aspect, then strike with simple, deadly efficiency. Tank commanders who survived these encounters reported the same pattern. The Sherman would approach a hedgerow, the driver would gun the engine, the tank would climb the earthen bank at an angle, and as the hull rose and the belly armor came into view, the Panzerfaust would strike. The explosion would gut the tank, would turn its interior into an inferno, would kill the crew before they understood what had happened. Survivors spoke of helplessness, of knowing the tactic that would kill them but possessing no alternative, of choosing between exposing their belly to anti-tank weapons or remaining trapped in a single field while German infantry maneuvered to flank and destroy them. Some tank crews refused to attempt hedgerow crossings, choosing to advance only along the lanes and roads where they became predictable targets for German anti-tank guns, positioned to cover these obvious routes. The armor that should have broken open the German defenses found itself trapped. Vulnerable, dying in fields barely larger than a suburban backyard. By mid-June, 2 weeks after the invasion, American progress inland had slowed to a crawl. Units that should have been racing across France were fighting for individual hedgerows, measuring advances in hundreds of yards rather than miles. Casualty rates climbed toward levels unsustainable for prolonged operations. Tank losses exceeded replacement rates. Division commanders sent urgent reports to higher headquarters describing the tactical problem, requesting solutions, demanding equipment or tactics that could break the stalemate. Engineers experimented with explosives, attempting to blast gaps through hedgerows. The explosions alerted German defenders and often failed to create breaches wide enough for tank passage. Bulldozer tanks pushed at hedgerows with limited success, their operators exposed to enemy fire. Their progress slow enough that German defenders could concentrate, fire on these obvious targets. Curtis Cullen watched his fellow tank commanders die in those hedgerows through June. He was 29 years old by combat standards, a sergeant commanding a Sherman in the 2nd Armored Division. Before the war, he had worked in a machine shop in New York, had spent his days solving mechanical problems, adapting tools for specific purposes, improvising solutions when proper equipment was unavailable. His mind worked in 3 dimensions, visualizing how components fit together, how force transferred through structures, how modifications could change function. On the beaches and in the first hedgerow battles, he applied this thinking to survival, to keeping his tank operational, to learning the terrain's deadly lessons without paying the ultimate price for that education. But survival was not enough. Cullen possessed the temperament that refuses to accept problems as unsolvable, that sees obstacles as puzzles requiring only the right approach, the correct tool, the proper application of force and leverage. The answer came to him not in a moment of brilliant inspiration, but through patient observation and mechanical logic. He watched how Sherman tanks approached hedgerows, noted the angle of climb, calculated the point at which the belly armor became exposed. He examined German beach obstacles, the steel beams and rails that engineers had cleared from the invasion beaches, now lying in piles awaiting disposal or repurposing. He thought about plows, about how farmers broke hard ground, about medieval siege warfare and how attackers had breached defensive walls. From these disparate elements, an idea formed. What if the Sherman did not climb over the hedgerow but cut through it? What if steel teeth mounted on the tank's front could slice through the earthen bank and tangled roots, allowing the Sherman to push through the hedgerow while maintaining level orientation, keeping its belly armor protected, emerging into the next field at fighting trim rather than exposed and vulnerable? Cullen sketched his design on whatever paper he could find. The device was brutally simple: steel prongs welded to the front of a Sherman tank, angled forward like the tusks of some mechanical beast. The prongs would penetrate the hedgerow's base, would use the tank's weight and engine power to drive through earth and root, would split the hedgerow rather than climb over it. He showed his sketches to other tankers, received skeptical responses, endured suggestions that he focus on fighting the war rather than playing inventor. But Cullen had watched too many friends die in burning Shermans to abandon the idea. He scrounged steel from German beach obstacles, obtained welding equipment from division engineers, and with the help of his crew and other willing soldiers, fabricated the first prototype. The initial test occurred in late June, in a field behind American lines where destroyed hedgerows could not benefit German defenders. Cullen's Sherman, fitted with the crude steel tusks he had designed, approached a hedgerow at moderate speed. The crew held their breath. If this failed, if the modifications weakened the tank's structure or caused mechanical failure, Cullen would face ridicule and possibly disciplinary action for modifying military equipment without authorization. The Sherman's bow struck the hedgerow. The steel prongs bit into earth and root. The tank shuddered, slowed, but continued forward. The hedgerow resisted, then yielded, splitting under the assault. The Sherman pushed through, emerged on the far side with its hull level, its guns bearing on the opposite hedgerow, its crew intact and its belly armor never exposed to hypothetical enemy fire. The soldiers watching erupted in cheers. Word of Cullen's invention spread through the division with the speed of all good news in combat. Tank commanders requested the device, offered to help fabricate more units, volunteered their crew's labor to weld and fit the steel tusks. Officers who initially dismissed the idea reversed their positions when shown the test results. Within days, division engineers had refined Cullen's design, had created templates and welding jigs to standardize production, had organized work parties to manufacture the devices in quantity. Steel from German beach obstacles, the very barriers meant to stop the invasion, was cut and shaped into the tools that would break the hedgerow stalemate. There was perfect symbolism in this. German defenses transformed into American solutions. Enemy steel repurposed to defeat enemy tactics. The device acquired a name: the Rhino. Soldiers called the modified Sherman's Rhino tanks, recognizing in the steel tusks a resemblance to the horns of that powerful beast. By mid-July, most Sherman tanks in Normandy carried Rhino attachments. Production expanded beyond the 2nd Armored Division. Army ordnance units established assembly lines, turning out Rhino kits by the hundreds. Tank crews that had faced hedgerows with dread now approached them with confidence. The tactical equation had reversed. Where German defenders expected vulnerable American tanks climbing hedgerows and exposing their bellies, they encountered Shermans plowing through hedgerows at speed, emerging already oriented toward the enemy, guns firing, breaking through prepared positions before defenders could react. The German perspective reveals itself through the changing tone of their combat reports and prisoner interrogations. Early June reports from Normandy expressed confidence in the hedgerow defenses, noted with satisfaction the heavy American tank losses, predicted that the invasion would be contained and eventually thrown back into the sea. By late July, these same units reported confusion, described American tanks breaking through previously impregnable positions, noted declining morale as their tactical advantages dissolved. One German officer captured in August told his interrogators that the American ability to modify equipment in the field, to solve tactical problems through improvisation, demonstrated a flexibility that German doctrine could not counter. "We planned for the enemy we expected," he said. "They became a different enemy." The transformation in American tactical effectiveness was dramatic. Operations that would have required days of bloody fighting to advance a few hundred yards now achieved breakthrough in hours. Tank infantry teams learned to exploit the Rhino's capabilities, coordinating assaults that used the modified Shermans to smash through hedgerow defenses, while infantry followed to clear German positions before defenders could reorganize. The hedgerow country that had seemed an impassable barrier became merely difficult terrain, an obstacle that slowed but did not stop American armor. By late July, when Operation Cobra launched the breakout from Normandy, Rhino-equipped tanks led the armored columns that finally achieved the mobile warfare American planners had originally envisioned. The liberation of France accelerated from grinding attrition to rapid maneuver, and a significant factor in this acceleration was a sergeant's field improvisation built from scrap steel and combat necessity. Curtis Cullen received the Legion of Merit for his invention, was promoted, became briefly famous in press accounts celebrating American ingenuity. He deflected credit, insisted that any tank commander would have developed a similar solution given time and materials, claimed his only advantage was working in a machine shop before the war. This modesty was characteristic but also strategic. Cullen understood that armies are vast bureaucracies that resist individual initiative, that value procedure and authorization over improvisation and creativity. By minimizing his own role, by presenting the Rhino as an obvious solution that anyone might have discovered, he protected himself from the institutional resistance that often greets unauthorized innovation. He also understood a deeper truth. The Rhino worked not because of individual genius, but because American military culture, despite its bureaucratic tendencies, permitted and eventually rewarded field improvisation in ways that more rigid armies did not. The contrast with German military culture was stark. The Wehrmacht possessed superb tactical skills, experienced soldiers, and often superior equipment. What they lacked was the flexibility to adapt when their doctrines encountered unexpected realities. German armor doctrine emphasized combined arms operations, careful planning, and exploitation of superior technology. When Normandy's terrain negated their technological advantages and complicated their doctrine, they had no mechanism for rapid tactical innovation at lower levels. German tank commanders fought brilliantly within their doctrinal framework, but lacked the cultural permission to experiment outside it. A German sergeant who proposed modifying tank armor without explicit authorization would face court-martial. not commendation. The rigidity that made German operations so precisely effective when conditions matched expectations became a fatal weakness when conditions changed. The recurring symbol in this story is steel itself. German beach obstacles constructed of steel rails were meant to rip apart Allied landing craft, to turn the invasion beaches into graveyards of wrecked vessels and drowned men. Instead, American combat engineers cleared these obstacles and American tankers transformed them into tools of liberation. The steel that Germany had shaped to defend occupied France became the steel that freed France. This transformation represented something fundamental about American material culture and industrial philosophy. Steel was not sacred, not permanently committed to a single purpose. It could be cut, welded, repurposed, adapted. The beach obstacles were not memorials to German engineering, but simply metal that could serve new purposes in different hands. This utilitarian approach to materiel, this willingness to cannibalize and repurpose, reflected a democratic understanding that tools serve people rather than people serving tools. The Rhino's impact extended beyond its immediate tactical effectiveness. It demonstrated to American soldiers that they possessed agency, that they were not helpless victims of terrain or enemy tactics, that problems could be solved through initiative and creativity. This psychological effect cannot be quantified but shaped the American Army's evolution through the remainder of the war. Units developed other field modifications, additional armor welded to vulnerable areas, improvised communication systems, adaptations to weapons and equipment. Higher headquarters, initially resistant to unauthorized modifications, learned to encourage and systematize these innovations. The relationship between field soldiers and rear echelon planners evolved from top-down command to collaborative problem-solving. When frontline units identified problems, they increasingly developed solutions rather than simply requesting help from higher headquarters. By August 1944, as American armies broke out of Normandy and raced across France, the hedgerow battles had become history, their lessons absorbed into doctrine and training. New tank crews arriving in France found Rhino attachment standard equipment, learned to use them without necessarily knowing their origin story. The innovation had become normalized, its revolutionary nature forgotten in the rush of mobile warfare. Colin himself remained a tank commander, fought through France into Germany, survived the war, and returned to New York where he worked in manufacturing until retirement. He gave few interviews, avoided publicity, lived the quiet life of a man who had done extraordinary things but did not define himself by them. The German soldiers who died in those Norman fields never understood the larger context of their defeat. They fought bravely, used terrain skillfully, inflicted heavy casualties on American forces, and still lost because their enemy possessed advantages that transcended battlefield tactics. American industrial capacity could replace lost tanks faster than German anti-tank weapons could destroy them. American logistics could sustain armies across thousands of miles of ocean. American tactical culture could solve problems in the field without waiting for solutions from distant headquarters. These systemic advantages, not superior individual courage or tactical skill, determined the war's outcome. The Rhino exemplified these advantages in miniature. A problem recognized, a solution improvised, implementation achieved through available materials and collective effort, success multiplied through industrial production and organizational flexibility. The hedgerows themselves remained after the war, continue standing today, still mark field boundaries in Norman countryside. Tourists visit Normandy beaches, walk where men died, contemplate the price of liberation. Few visit the inland fields where the hedgerow battles occurred, where the invasion nearly stalled, where a sergeant's improvisation helped transform stalemate into breakthrough. There are no monuments to the Rhino, no markers explaining how German beach steel became American breakthrough tool. The fields are farmed, the hedgerows maintained, the landscape peaceful and productive. Only the soil remembers the steel that cut through it, the tanks that plowed through ancient barriers, the transformation of agricultural obstacles into military history. The technical specifications of the Rhino were unremarkable. 4 or 6 steel prongs, each about 3 feet long, welded to brackets mounted on a Sherman tank's bow. Total weight perhaps 500 pounds, added to a 30-ton vehicle. No complex engineering, no precision manufacturing, no rare materials or specialized knowledge required. Any competent welder could fabricate the device in a few hours. Its effectiveness derived not from technical sophistication, but from correct identification of the tactical problem and appropriate application of mechanical force. This simplicity was itself significant. Complex problems do not always require complex solutions. Sometimes they require only clear thinking and practical action. The story of the Rhino became part of American military mythology, was retold in training schools and officer courses as an example of initiative and innovation. These retellings often simplified the narrative, reduced Cullen to a lone genius having a brilliant idea, ignored the collaborative development process and the organizational flexibility that allowed field modifications to become official doctrine. The mythologized version served pedagogical purposes, but obscured the deeper truths about why American forces succeeded in World War II. Individual brilliance mattered less than systemic advantages. Institutional flexibility, material abundance, and cultural values that permitted improvisation and rewarded results over procedure. By the winter of 1944, as American armies approached Germany's western frontier, the Wehrmacht had learned to respect American tactical adaptability. German intelligence reports noted the speed with which American units identified and solved problems, the freedom American junior officers and NCOs possessed to modify tactics and equipment, the seemingly unlimited American capacity to learn from mistakes and implement improvements. These reports concluded that American material superiority alone did not explain their military effectiveness. The Americans fought differently, thought differently, organized differently. They approached warfare as a problem-solving exercise rather than an exercise in executing predetermined doctrine. This approach was inefficient by German standards, wasteful of resources, lacking in elegance. It was also devastatingly effective. The Rhino disappeared from American tank modifications after the Normandy campaign. Once American armies broke out into open terrain, once mobile warfare replaced static hedgerow battles, the device became unnecessary weight-reducing tank speed and maneuverability. Crews removed the Rhino attachments, set them aside, returned to standard tank configurations. The steel prongs that had broken the hedgerow stalemate ended their service in salvage yards, were melted down for scrap, perhaps reforged into peacetime products. Their brief existence as military equipment left no physical trace. Only photographs and combat reports document their appearance and use. Yet their impact on military history was permanent. They had solved a problem that threatened to stall the liberation of Europe, had saved uncounted lives, had demonstrated principles of tactical innovation that would influence American military thinking for generations. The sound of a Sherman tank plowing through a hedgerow was distinctive. Witnesses described it as a rending, tearing noise, earth and root surrendering to steel and mechanical force, the squeal of stressed metal, and the roar of an engine at full power. It was the sound of obstacles yielding, of barriers breaking, of problems being solved through direct application of power and ingenuity. German soldiers who heard that sound learned to fear it, learned that their defensive positions were no longer secure, that the terrain advantages they had relied upon were dissolving under American persistence and innovation. For American soldiers, that sound represented hope, represented proof that they were not helpless victims of terrain or enemy tactics, represented the democratic principle that collective intelligence and initiative could overcome any obstacle. Curtis Cullen died in 1963, 19 years after his invention helped break the Normandy stalemate. His obituary mentioned his military service and his Legion of Merit, but focused primarily on his civilian life, his family, his work in manufacturing. The Rhino merited a single sentence. This proportion was probably accurate to Cullen's own sense of his life's meaning. He had served, had done what needed doing, had returned to normal life without allowing his wartime experiences to define his identity. He represented a generation that fought a necessary war and then moved on, that declined to treat military service as the peak of their existence, that viewed citizenship as including but not limited to military duty. The modesty was itself a kind of strength, a refusal to inflate wartime necessity into peacetime superiority. The liberation of France cost tens of thousands of American lives, required months of brutal combat, demanded resources on a scale unprecedented in military history. Within this vast story, the tale of a sergeant's field modification occupies a small space, a footnote in comprehensive histories, a specialized subject in technical studies of armor warfare. Yet footnotes sometimes illuminate larger truths more clearly than main narratives. The Rhino story reveals how wars are actually won, not through grand strategy alone, but through countless small solutions to tactical problems. Not through predetermined doctrine, but through adaptation and improvisation. Not through individual genius, but through cultures and systems that enable and reward practical innovation. The German expectation that hedgerow defenses would contain the American advance rested on reasonable tactical analysis. The hedgerows provided extraordinary defensive advantages, channeled attacker movements into predictable patterns, negated Allied armor superiority. German commanders who studied the terrain concluded that properly defended, Norman hedgerow country could stall American advances for months, perhaps indefinitely. These conclusions failed to account for American cultural and institutional characteristics that transcended purely military calculations. They did not anticipate that American soldiers would refuse to accept stalemate as permanent, would experiment with solutions, would possess the cultural confidence to modify official equipment based on field experience. In the final accounting, the Rhino represented something more symbolic than tactical. It demonstrated that democratic armies fighting for liberation possessed advantages that authoritarian armies fighting for conquest could not match. The freedom to question doctrine, to experiment with unauthorized modifications, to reward results over procedure, to trust that sergeants might solve problems that colonels could not. These freedoms were extensions of the democratic principles the Allies claimed to defend. German tactical excellence and superior technology could not overcome these systemic advantages. The best tank in a rigid system was less effective than an adequate tank in a flexible system that permitted adaptation and innovation. The steel prongs, welded to Sherman tanks in Normandy fields, in the summer of 1944, cut through more than hedgerows. They cut through the myth that quality necessarily defeats quantity, that superior individual technology ensures victory, that rigid doctrine and centralized control represent military excellence. They demonstrated that mass-produced equipment in the hands of soldiers empowered to adapt and improvise could defeat specialized equipment operated within doctrinal constraints. They proved that the same cultural characteristics that made America chaotic and inefficient in peacetime made American forces remarkably effective in war. The tendency to question authority, the faith in practical solutions over theoretical elegance, the assumption that problems can be solved if enough smart people work on them with sufficient resources. The hedgerows stand today, green and peaceful, marking field boundaries in a countryside long since recovered from war. The steel that broke through them has long since been recycled, transformed into products serving civilian purposes. The men who fought there are mostly gone, their memories fading into history, their stories preserved in archives and documentaries and occasional commemorations. What remains is the lesson, the understanding that freedom means more than political philosophy, more than slogans and declarations. Freedom means the ability to think independently, to solve problems creatively, to modify tools and tactics based on experience rather than waiting for authorization from distant authorities. It means trusting sergeants to understand their immediate situations better than headquarters might, trusting practical mechanics to innovate where professional engineers have failed, trusting that collective intelligence distributed across an organization will discover solutions that centralized planning cannot. Curtis Cullen, standing beside his Sherman tank in a Normandy field in June 1944, sketching crude diagrams of steel prongs, represented these principles in flesh and sweat and motor oil. He was not a general or a scientist or a professional inventor. He was a sergeant who fixed cars before the war, who understood metal and force and mechanical advantage, who refused to accept that a problem without an obvious solution was an unsolvable problem. The steel tusks he designed, the rhino that bore his innovation into battle, broke through hedgerows and German defenses and the myth of American martial inferiority. They were democracy's answer to dictatorship's challenge, improvisation's response to rigid doctrine, abundance's triumph over scarcity. They were, in the end, simply steel and weld and practical thinking applied to an immediate problem. But sometimes the simplest tools carry the deepest meanings, and sometimes a sergeant's improvisation changes history more than a general's grand strategy. The hedgerows remember. and the steel that cut through them left marks deeper than any plow could make. Marks that scored into history the truth that freedom without innovation is hollow, and innovation without freedom is impossible. And together they constitute a power that all the tigers and panthers and perfectly executed doctrines cannot withstand.